Here we're showing the distances between four different cities, and we're asked to calculate the length BV. So BV is part of this triangle at the top. We can see that this is 33, that this is 240 km, and that this is 200. So we've got a non-right angled triangle with two sides and an angle. We're trying to find a missing side. So because we don't have pairs, it's not the sine rule, it's got to be the cosine rule. So the cosine rule, which is on the front of your formula booklet, says that a squared equals b squared plus c squared take away 2bc cosine a. And the important thing is that this angle here is opposite this side. So because we want this length here, then a must be 33 cos a. So a squared equals, these two sides can be in either order. So 240 squared plus 200 squared, take away 2 times 240 times 200 cos, it's got to be 33. So on a calculator, if you did that, you would have got an answer of 17087. But that would be a squared, we just want a, so we need to take the square root of our answer. Square root of the answer would be 130.7 or 130.72. 130.72. The next one says calculate the distance GB. So GB is this length down here, and that belongs to this triangle. Let's see what we know about this triangle. Well, we know that this is 68 and this is 77. So we can say that this angle then must be 180, take away the sum of those two, which will give us an answer of 35. We know that this is 200 and we're trying to find this length here. Okay, we'll just call it x. So, non-right angled triangle, so we can't use SOHCAHTOA. So next we start looking for pairs if we can use a sine rule. Well, x is opposite 68 and 77 is opposite 200, so I do have two pairs I can use there. So because I'm trying to find a side, I'll keep that on top. So on your formula sheet, x over sine, in this case 68 because it's the one opposite, equals, keep the side on top, 200 over sine 77. So if I wanted to isolate the x, I'd do 200 over sine 77. Instead of divided by sine 68, I'd times by sine 68. And on a calculator, that should have come out as 190.315 or 190.32. Okay, in this question we're asked to find the area of the map. So we can say that the area is made up of two triangles, and from the previous question we worked out that the length of this side was 130.72 kilometres, and that the length of this side was 190.315. So if we split it into two triangles, we've got triangle 1 and triangle 2. So the area of triangle 1, it's a non-right angled triangle, so we're going to be using a half AB sine C. And the important thing with this formula is that the C is the angle in between the sides A and B. So if we choose to use this 33 to be the angle, then A would need to be 240 and B would need to be 200, or either way around. So for triangle 1, we're going to say a half times 200 times 240 sine, and then the angle in between is 33 degrees. So if you did that on a calculator, I think it comes out as 13071.3. Okay, and then same again, but this time for triangle 2. So the area of triangle 2. Well, with this triangle, we've got this side and this side, which means if we're going to use the angle in between, we need to know this angle here. So firstly, we'd have to say, well, it's going to be 180 take away 77 take away 68. So this angle is going to be 35. So we're going to do area of triangle 2 is a half times 200 times 190.315 times sine, and it's got to be 35 because it's the angle in between. So the area of that would be 10,916. So the total area is going to be area of triangle 1 plus area of triangle 2. which is 23,987.3 kilometres squared. The second bit to this question is where it says give your answer in square centimetres. So at the moment the lengths are in kilometres, but it's also a scale drawing. So the scale is 1 to 1 million. So that means 1 centimetre on the picture represents 1 million centimetres in real life. And we're trying to change this from kilometres. So that means then 1 centimetre on the drawing, if we were to change it to metres, well, centimetres to metres would be to divide by 100. So we can cancel a couple of zeros there. So 1 centimetre on the drawing is equal to 10,000 metres in real life. And then we can change 10,000 metres into kilometres. So 1 kilometre is 1,000 metres. So 1 centimetre again. If we were to convert this into kilometres, dividing by 1,000, 1, 2, 3, we'd get 10 kilometres. So this scale means that 1 centimetre on the drawing represents 10 kilometres in real life. Okay, but we're not just dealing with length, we're dealing with area. So if we've got 1 centimetre representing 10 kilometres, well, 1 square centimetre, or 1 centimetre squared, would be 10 kilometres by another 10 kilometres, or in other words, would be 100 kilometres squared. So we can say that 1 centimetre squared on our map is the same as, or is equivalent to, 100 kilometres squared in real life. So how do I go from 23987.3 kilometres squared into centimetres squared? Well, kilometres squared to centimetres squared would be divided by 100. So I need to divide this by 100, which would give me an answer of I put these the wrong way around. 239.873 centimetres squared. In this question, we're told that the bearing of V from M is 0.85. So the key thing about bearings is that we go from the north and we go in a clockwise direction. So if I'm starting here from M and going round to V, that's 85 as labelled. And the question says calculate the bearing of G from M. So G is over here. So we're going to a north. So we want to go all the way around from 85, because that's the M, all the way around till we hit G, which is going to be this line here. Or in other words, we want to add these three angles together, okay? Because we're going from M all the way around till we get to G, which means I'm passing through those three angles. So it'd be 85 plus 33 plus 68, which is 186 degrees. And then the second one says, find the bearing of M from V. So that time I'm starting here, and I want to go all the way around till I hit here, because that's where M is. So if I just draw that separately, starting at V, this is M, but we've got to go clockwise, so I've got to go all the way around. So what do I know about this diagram already? Well, I know that this is 85, and then because I've got a pair of parallel lines between the north angles, if that's 85, then I know that this angle here is going to be 180 take away 85. So this angle on the inside is 95. Okay. Then if we look about V, V is a point, so angles around a point make 360. So if I want to find what's left over, I'd have to do 360 take away 95, which is 265 degrees.